Alright, today we will try to answer the question, how does a computer store anything? Your phone has 256 gigabytes of storage. That number is on the box, it's in the advertisement, everyone nods, but almost nobody ever stops to ask, 256 gigabytes of what exactly? What is actually being stored in there? The answer is bits. And a bit is the most fundamental thing in all of computing. Everything inside your computer, your photos, your music, your Python code, and even the weights of a large language model. It all comes down to zeros and ones. This video explains why. Let's get into it. So, why do computers use only zeros and ones? Why not 10 digits like we do? The reason is physical. Inside every chip, there are billions of tiny switches called transistors, tens of billions of them, packed into a space smaller than your fingernail. Each transistor has two states, on or off. Electricity flows or it does not. There is no halfway. On becomes 1, off becomes 0. Now, why not use 10 voltage levels? 0 volts for 0, 1 volt for 1, and all the way up. Because the real world is messy. Heat, interference, noise, tiny fluctuations. 10 levels would cause errors constantly, but 2 states almost impossible to confuse. Binary isn't a limitation. It is the design decision that makes reliable computing possible. 1 transistor, 1 bit, a single 0 or 1. Not very useful on its own, but when you start grouping bits together, things scale fast. 4 bits make a nibble, 16 possible combinations. 8 bits make a byte, 256 combinations. This became the standard unit of storage. From there, kilobytes, megabytes, gigabytes. Each step multiplying by 1024. And why 1024, not 1000? Because computers count in powers of 2. And 2 to the power of 10 is 1024. So that 256 gigabyte phone. Do the math and you're looking at over 274 billion individual bits, 274 billion tiny switches, each one either on or off, right now inside your pocket. Let's look at how binary actually represents numbers. This is where it usually clicks. In decimal, the system we use every day, each column is a power of 10. Ones, tens, hundreds, thousands. Binary works exactly the same way, but with powers of 2. From right to left, ones, 2s, 4s, 8s, 16s, 32s, 64s, 128s. Take the number 42. In binary, that is 0, 0, 1, 0, 1, 0, 1, 0. 1 in 32 column, 1 in 8 column, 1 in 2 column. 32 plus 8 plus 2. 42. Exactly. And 255 in 8 bits is all ones. Every column active. That is the maximum value of a single byte. This is why you see 255 everywhere in tech. RGB colors, port numbers, network masks. 1 byte, 8 bits. Max value 255. Oh, and 4 bits, that is called a nibble. And a nibble can represent 16 values, which is exactly 1 hexadecimal digit. That is why this channel is called Hex 1000. Hex as in hexadecimal, the number system built on nibbles. Okay, so we can store numbers, but what about text, images, sound? Here's the key insight. Once you can store a number, you can store anything, because anything can be mapped to a number. For example, text. Engineers decided the letter A maps to 65, B is to 66, C is 67, and that standard is called ASCII. Today, we use Unicode. Every language, every emoji, still just numbers. And what about color? For every pixel on your screen, 3 numbers: red, green, blue, 0 to 255 each. The orange in this channel's logo: 255 red, 140 green, 0 blue. 3 bytes per pixel. And sound. The audio is measured by thousands of times per second. Each measurement is a number. Your music is a very long list of numbers. And what about code? When you write print, Python eventually translates that into binary patterns. The CPU understands as instructions. Same foundation all the way down. Now, where does this actually show up when you're using large language models like GPT? It's tokens. When GPT-4 reads your message, it doesn't see the text. It converts each word or a part of a word into a token ID, a number. The model processes a sequence of integers, bits all the way down. The model weights, a 70 billion parameter model has 70 billion numbers in memory. Each weight is typically a 16-bit float, 2 bytes. That's 140 gigabytes just to hold the model itself. And what about context window? When people say a model has 128k context, they mean it holds roughly 128,000 tokens in RAM at once. Each token is a vector, thousands of numbers. More context means more bytes, more to compute, more cost. Machine learning is not magic. It's linear algebra executed on top of billions of physical switches. Everything is bits, text, images, sound, your code, weights of a large language model that can write poetry, debug software, and explain the universe. All of it. Zeros and ones. Transistors switching on and off. Billions of times per second. Once you see it, you start seeing it everywhere. And that is what this channel is about. Next video is going to be about strings, but not how the text is stored, more like how a large language model actually reads the sentence you just typed. Tokenization, embeddings, meaning vectors. I'm Hex1000, logic behind the code. Signing out.